Right, matrix, let's look at collinear points. Okay, sometimes they ask you about collinear. If 3 points A, B, C lie on a straight line, then the points are said to be collinear, and the following principle applies. The gradient of AB is the gradient of BC. Now let me show you. If you've got this here, okay, there's A, there's B, and there's C. Collinear means that these 3 points are on the same straight line. So the gradient of AB must be the gradient of BC. They've got to be, it can't be different. They're on the same line and they have the same gradients, because on a line, the gradient is constant. Okay, good. Now let's explore this. Here's a lovely question. Watch this. For the matrix, the following points lie on a plane A, B, and C. Determine the value of K if A, B, and C are collinear. Careful now. What do we know? If they're collinear, the gradient of AB is the gradient of BC. It's always AB to BC. Okay. Now, if we look at that, so A is 1, 2, B is 3, 1, and C is that. Now, let's go and we'll take our 3 points, and we know that the gradient of AB is equal to the gradient of BC. Now, how do we get the gradient of AB? Well, pretty straightforward. You can go in any order. We can say 2 minus 1 divided by 1 minus 3. Or you could go 1 minus 2 over 3 minus 1. So you get the gradient of AB. The gradient of BC would be, if you can go this way if you want to, you can say K minus 1, negative 3 minus 3. Notice I reversed the order a bit. Here I went, or you can go 1 minus 2, 3 minus 1, K minus 1, minus 3 minus 3. You could have also gone 2 minus 1, 1 minus 3 as well. Okay, now if you look at this, what a pleasure. We can then simplify. That's minus 1 over 2, K minus 1 over negative 6. And if you get the LCD, we can multiply by, or you can just cross multiply, bring the minus 6 up into 2, and all we do is solve for K. So we've got 6 is 2K minus 2, and you've got 8 is equal to 2K, and K is equal to 4. So be careful with that. That's quite a nice one. Another thing, grade 11s and 12s, the angles of inclination. If that's an acute angle, here's some rules you might want to do. The tan of that angle is the gradient of the line AB. Okay, so that angle of inclination, it's acute, almost the first quadrant angle, and to get theta, all you do is go shift tan of that gradient of that line. Okay, that's a wonderful rule when you have an acute angle, and your gradient will also be positive. Okay, so just check this out. That's quite an important thing. Okay, now what about if it's obtuse, if you have a second quadrant angle, bigger than 90, less than 180? Well, in this case, your tan theta is the gradient of the line, and to get it, I've got a lovely rule. You might want to write this down. Theta is equal to 180 minus tan of the positive gradient. Stick to this. If you stick to it, so the gradient here will be negative. You'll get a negative number. I'm going to show you how to do it. You get a negative number in there, but that means that the gradient is negative. The line is sloping to the left. The angle of inclination is obtuse, and tan theta is a negative number. So what you do is you go theta is 180 minus the tan, shift tan, and you take that positive number. It works like a bomb. Okay, here we go. Now look at an example. We want to find the sizes of all those angles. Well, what do we know? For this angle alpha, we can say, if you look at this, if you want alpha, we can say that the tan of that alpha is the gradient of AB. Okay, cool. How do we get the gradient of AB? Well, easy. 4 minus, careful now, negative 3, and 3 minus negative 4. Okay, and this is going to give us our gradient. So what do we have? This is 7 over 7, which is 1. That's positive. The line is sloping to the right. The gradient is positive. It's an acute angle, a first quadrant. How do we get that theta? We simply say shift tan 1, and we get 45. So we know that that is 45. So you work tan of the alpha is the gradient of AB, work out the gradient, and there you go. And we've got that as 45. Okay, what about beta? Now be careful. The tan of beta is the gradient of AC, so we work it out. 4 minus negative 3, 3 minus 6, and it's 7 over negative 3. Now that's a negative number. It's obtuse. How do we then use it? Use this little rule now. Watch here. Tan of that, 180 minus shift tan of the positive version. And if you do that in your calculator, you're going to get 113. Okay, so important. Stick to these rules. Okay. I will put them back on Facebook later on this evening. I'm going to actually put them on and you can go and check it out and write them down. They're so important, these rules. Okay, now look at this. Now to get theta, we've got that as 45, 113. And did you notice beta is theta plus alpha? The exterior angle of the triangle is the sum of the interior opposite. You've got those two, so how do we do it? We then say beta is 113, theta plus 45, and off you go. You can then subtract and you get this as 68 degrees. Okay, please guys, master this stuff, and we will be back on Matrix Uploaded for more analytical geometry. Have a wonderful time doing this wonderful section, and Mzansi, Sanbonani for sure. Let's rock and roll. See you soon.